Okay, hello everyone. I'm Jacopo Fior. Thank you for the introduction. And today I want to talk about portfolio allocation based on time series analysis. This will be an introductory talk because I'll try to stay really high level because I'm trying to present a couple of different works in the presentation. And yeah, let's delve into it. So as an agenda, I will just give you a short context overview, then present to you the baseline over which these two works that I will be presenting builds upon, and then I will, of course, focus on the two different applications and introductions. So, buy and hold strategy. Why I'm talking about buy and hold strategy? This is one of the most common, probably the most common one as a trading strategy, and it's quite simple. It consists in just buying stock and holding them for a relatively long period of time. What does it mean, relatively long? It can mean weeks, months, years. In our experiments, we usually work with 1, 2, or 3 years because we are really trying to build stable portfolios. But portfolios can be updated even with a shorter time frame. It's just different from short-term trading like intraday and high frequency, because in those kind of strategies you buy and sell continuously depending on the market price. You also use some other kind of methods that are not just buying stock but short selling them. That means selling them before having them and buying them later. But in buy and hold, everything is easier because you just buy and wait. So it's a passive management strategy, and it's a bullish one. Bullish means that you buy stocks that you expect to grow in the time during which you keep the portfolio. So what are the basics of buy and hold strategy? You want to maximize the returns and you want to minimize risk. How do you maximize the returns? By buying stocks that you expect will grow much more than all the other ones. And to minimize risk, you try to spread bets over different group of stocks. In this way, you try to diversify the portfolio. So if, let's say, pharmaceutical sector goes down, maybe the fintech does not. And so you try to have to invest in all of the sectors equally. In all of the sector, what is done usually, and I'll show you a different way to do that. So what is the baseline? The baseline is this plan. This plan is an approach that has been published. The link is quite small, but you will find it. It's an approach that has been published 6 years ago, and is an unsupervised item set-based approach to generate stock portfolios. How does it do that? It takes really high level again. It takes in input a minimum diversification level and a taxonomy that aggregates stocks. In this case, in the case of this plan, as most of the literature, it aggregates stocks into sectors. What it gives in output, a ranked list of candidate stock portfolios that, of course, satisfy the minimum level, the minimum diversification level, and try to maximize the expected return. It's a whole framework, but the gist is in this slide. So what it does is in this slide. What are the two improvements that we proposed building upon this plan? First of all, as I was saying before, at this moment, well, at that time, most of the works tried to diversify based on sectors. But why using just sectors? Since stocks are time series, for our goals can be represented as just one time series or a multivariate one in some cases. And since there are multiple approaches to time series clustering, why not using these kind of approaches to build clusters and try to diversify over clusters instead of over stocks? And so this is the first improvement that we try to apply. The second one is to introduce, to actually not really introduce a portfolio level optimization step, but to use this plan as a step in portfolio optimization. Portfolio optimization is a full area of work that builds upon Markowitz, and which I'll show you later. So first application, cross-correlation for portfolio diversification. It's quite easy. So since we get the data, in this plan, usually we put them as a transactional representation to do the item set-based portfolio generation. And as I said before, it takes in input a taxonomy. What we do here is just to add this step. I don't know if you see the laser, I don't. The step with time series representation and cross-correlation analysis. So instead of having the taxonomy over sector, we have the taxonomy over stocks, and we give it in input to the system. So as a clustering method, we use K-shape. We use K-shape because it's scalable and it outperforms a lot of other methods constantly, so it's a standard. It's not really a new method, but it's quite good, and it is of course based on k-means, as you can get from the name, and employs cross-correlation as a similarity measure. In cross-correlation, we can also skip about that, but anyway, cross-correlation just consists in having two time series and sliding one over the other by one step at a time and calculating the internal product of the two time series. This is important because it gives a shift invariance similarity measure that is important in stocks because there are days in which stocks are not traded because markets are closed, and so having a shift invariance measure is necessary actually. Co-occurrence matrix is just because the method is not deterministic, so we run it 100 times and do a co-occurrence matrix, and we generate these kind of clusters in which we have multiple stocks aggregated together. How can we compare clusters with the standard sectors? We can show that each cluster have we can show that the taxonomy presents intersector stock similarity and intrasector stock dissimilarity. What does this mean? Intersector stock similarity means stocks between different sectors that are actually quite similar one with the other. While intrasector stock dissimilarity represents stocks that are in a single sector but are quite different one from the other. So this is an example of a clustering outcome, and you can see that the clusters are on the left. I don't see the laser actually. Clusters are on the left, and you can see the distribution of stocks in the various sectors for each cluster. So to see some example of intersector stock dissimilarity, let's say cluster 9, the one with the light yellow highlighted numbers, you can see that there are in the same cluster all of stocks of energy sector, so it's quite focused on the energy sector, this cluster, but there are also two stocks of the material sector. We looked into that, and those stocks are actually stocks in the mining field. So we can all see that they are quite correlated. It's a nice thing that we find that they are correlated. For intrasector stock dissimilarity, instead, we can see, for example, the sector industrial is divided into a lot of different clusters. And looking into that, you can see that I see that. You can see that these three, and these four are all belonging to different subsectors. So we can see that the clusters also find other kinds of information that the sectors do not provide, and you need some finer taxonomies to see that. So just a really short analysis of the equity results. We can see that, for example, the one with a lot of x's is the cross-correlation version of this plan, and the line is just the market, what is happening to the index. So we can see that between October and November of 2009, there was quite a dip in which both the system, the original Displan system, and the index took a hit, while the cross-correlation version was better diversified and was able to outperform the other ones and never lost the what it earned over the others two. You can see that actually sometimes Displan outperforms so much the index that the cross-correlation version doesn't really improve over that, and it is actually because those two were the exact same portfolio selected. So it's not always dependent completely on the taxonomy, and actually the taxonomies add a lot of similarities, as you can see here. So it's a common event. So I try to be really fast over this part. Portfolio level optimization is the second contribution. Okay. So we try to use Displan as a step, an early portfolio pruning step actually, in a bigger approach that is an hybrid of Displan and an optimal investment portfolio selection that is the Markowitz mean-variance model. This is a really high-level presentation of Markowitz model. So you can see that we try to maximize this function for those constraints, and this function is composed of the expected portfolio return. So how much we expect the portfolio to earn in the long run. The return dispersion, this is the variance, so how much the stocks actually change their returns in the expectations that we have. So of course, the higher the return dispersion, the more risk is in the portfolio, because you can have, with the higher variance, you can have higher returns, but also bigger drawdowns. And so for this reason, we have the lambda, that is the risk aversion coefficient, that the higher it is, the most averse to risk is the portfolio, because if you put it to 1, we are going to lose the second part of the equation. Just a bit on the constraints. What does it mean that we want to have these kind of constraints? It means that W equals to 1. W is the vector of all the weights that we give to the various stocks that we are selecting. So mean variance model by Markowitz is usually used over the whole data set. So you have 100 stocks, you try to test it over the 100 stocks, and you want the weights to sum to 1, of course, and we are not short selling, so again we want the weights, each weight we want to be greater or equal to 0. So we're just selecting some stocks, and for those stocks we are saying we want this much of that particular stock. What is the worst thing about this method is that if you have 500 stocks, it's quite a lot computing intensive, and also it's just focused on the stocks. You have a lot of stocks and you try to make a portfolio. You are not selecting how many stocks you want in the portfolio or any other kind of constraints. So we try to add some constraints. First of all, we put it, we transformed it on portfolio level instead of stocks. So we test it on multiple portfolios that are the one that we selected with Displan at the beginning. And in this way, we are reducing the computational intensity of the task, the computational cost of the task, because we are just running it on smaller portfolio, usually 7 to 10 stocks for portfolio. And also we add some constraints based on fundamental analysis. and on technical analysis. Let's see them quite fast. But on fundamental analysis, we usually assign a score to each stock based on the virtuosity of that stock for a particular fundamental factor. That can be the PTDA or any other kind of factors. And for the most virtuous stocks in the whole dataset, not just on the portfolio, we assign a 1, and for the other we assign a 0. So it's completely discrete, and it's easy to assign a score to each stock, and then you can easily combine them to give the portfolio a score. We focus just on indicators that have been proved to be effective for stocks with high returns. Why is this? Because we pruned with this plan all of the stocks that didn't give us nice returns. So it's can be a correct assumption. And of course, this is a system that is expert driven. So the sectors and all the indicators used can be selected by the expert. As a technical analysis step, again, it's quite similar. We just use technical analysis to try and look into the trend of a particular stock. So we will have stocks that have an expected trend that is more increasing than some other stocks, and we have a lot of different indicators, a lot of different technical indicators. And again, we create a new constraint on the technical analysis. In this way, we are really trying to add some information that is only in the time series to the portfolio selection in order to optimize the portfolio. And we can see, just as an example of the results, there are a lot more results in the paper, so if you want to look at them. But here I just compared the APP method with some real-world index, real-world portfolios by JP Morgan or Pioneers or Morgan Stanley. So these are quite good portfolios, at least quite good providers. And we can see that the portfolio generated in this way is quite more stable than the other. And yes, of course, it follows the market in some ways. So it's not outperforming everything, but it actually outperforms the market, outperforms the competitors, outperforms this plan and Markowitz on their own. And of course, if you try it we tested it on bearish periods, or periods that goes usually down, and it usually stayed on top also on the drawdowns. Of course, without earning much in those periods, but better losing less than the market actually. So just conclusions, but I already talked about the conclusions. So the buy and hold strategy achieves good results, especially when the portfolios are well selected and well diversified. And yeah, the cross-correlation based taxonomies usually improve diversifications. All of the tests we did had this kind of results. And combining item set based and optimization based selection provides better results than the two methods on their own. So yeah. That's it. Thank you, and you can find my email.